confront them? From watching them, it seems like they only care about eating food and surviving. Have you ever, out of curiosity, tried to approach a squirrel? And when you got a certain distance away from it, did you see it notice you? And when you tried to get even closer, it eventually ran off to hide? Did it know that you were intentionally approaching it? Could it tell what you wanted to do, or did it only move away because a random figure was getting close to it?
In this video, we're going to explain our research proposal to you to find out more about how aware animals are of differences in threat level. We will be using eastern gray squirrels and approaching them facing forward and backward to see if they feel the difference in threat level. We are interested in how close a squirrel initially allows an approaching figure to get to it before it flees, known as flight initiation distance, and how many times the squirrel will allow the threat to continuously approach it before it decides that it has had enough and runs up a tree or somewhere we can't reach it.
Similar behavior has been observed in past research on deer, which has shown that different methods of approaching affects the deer's flight initiation distance. Flight initiation distance is the closest distance a predator can get to an animal before it decides to run away. It is based on the theory that animals decide to flee or not to flee depending on the cost of fleeing compared to the cost of staying. Researchers have examined factors such as speed, direction of approach, gaze, and whether or not the experimenter simulated gun carrying while approaching. This study found that the deer fled at greater distances when they were approached faster and more directly.
Some questions we want to answer are: do animals respond differently to different levels of approaching threats? How are flight initiation distances influenced? And how is the number of times the animal allows the threat to continue approaching it influenced?
To answer these questions, we plan to study the eastern gray squirrel because it is common, has many different predators, and has been used before in research regarding flight initiation distance. We will set up a large artificial environment so we can be in control of different factors that can affect the squirrel's behavior. The environment will be around 150 feet by 150 feet in area and will be filled with grass and have a single tree for squirrels to retreat to. There will be a single food source 10 feet away from the tree. This food will be incentive for the squirrel to stay at that spot. We will place taxidermy models of typical squirrel predators such as foxes on wide remote-controlled platforms.
While the squirrel is eating from the food source, we will have the predator approach. The data we are interested in collecting is the squirrel's flight initiation distance for each time we approach it and the number of times we can approach it before it runs up the tree. First, we will test the squirrel with the predator facing forward, which is the highest level of threat, then backwards, which is a lower level of threat, and then with just a moving platform, which should be the least threatening.
This is what one trial would look like. We'll use the platform to approach the squirrel, let the squirrel run away until it stops, then make the platform approach the squirrel again. We will continue this until the squirrel runs up the tree.
The expected outcome of our research would be that the squirrel's flight initiation distance is higher when the model animal is facing it, lower when the model animal approaches it backwards, and lowest when just the platform is approaching. We would also expect the number of times the squirrel allows us to approach it to be lower at higher threat levels. Other possible outcomes include that there is no difference in responses at different threat levels, or that flight initiation distance increases at lower threat levels and number of permitted approaches increases at higher threat levels.
To support our expected outcomes, we have collected data from squirrels around the UMass campus. One of us approached squirrels and the other measured flight initiation distances while the first experimenter continued to approach the squirrel. We took our measurements using a tape measure and ran it to the nearest half foot. Once the squirrel retreated to its refuge, the total number of approaches was recorded. We found that the flight initiation distance decreases when the experimenter approached the squirrels while facing away, shown in red, compared to the trials where the experimenter was facing the squirrels, shown in blue.
Our pilot data tells us that there may be a significant relationship between threat level and flight initiation distance. On average, when approached by a forward-facing threat, the squirrels would retreat at a greater flight initiation distance, 17 feet, compared to when a backward-facing threat approached, 10.7 feet. In terms of the number of approaches permitted by the squirrel before they retreated to a refuge, the data appeared to be random when comparing front and backward-facing threats.
However, there are flaws in our pilot data collection methods tied to external factors that we couldn't control. Some of the challenges we faced included varying proximity to refuge. Distance from a refuge does affect gray squirrel flight initiation distance. In the proposed experiment, proximity to a refuge would be kept constant. So, varying stress hormone levels tied to human exposure is another factor that can affect squirrels' anti-predator response. To correct this, human exposure will be kept constant. Additionally, our data was affected by varying squirrel activity. A reaction to an oncoming threat depends on what the squirrel is doing at the time when it senses the threat. In the proposed experiment, squirrels will be eating when they are approached by the threat. These are our proposed expenses for our research. This includes squirrel care, remote control platforms, and our artificial environment for a total of $527,870.
Implications of our research include creating a better understanding of threat assessment relating to flight initiation distance and permitted approaches in a retreating animal. Also, our research can aid in understanding threat assessment in animals such as squirrels and other taxa. Our research can also provide insight on the uniqueness of how different animals respond to environmental triggers. Additionally, it can reveal certain patterns of how animals behave under varying environmental conditions. Finally, it can provide a greater understanding of one of the many facets associated with threat response in animal behavior.
Just go.